Hello everyone, my name is Logan Colone, and I'm currently enrolled at Cape Fear Community College in Wilmington, North Carolina in the Associates in Engineering degree program. Today I'll be giving a presentation on my MATLab tutorial solution manual that applies to the course Physics 2. Today we will be discussing how to find the source voltage of a direct current circuit that's composed of a battery, a capacitor, and an inductor, which is also known in the Physics 2 realm as an LC circuit. First, I'd like to define some variables so that we can all be on the same page. In this presentation, Q will stand for charge in coulombs, L is the inductance in henries, C is the capacitance in farads, Q max is the maximum charge that a capacitor can hold in coulombs, and T is the time in seconds. As you can see here, we have a circuit diagram, schematic rather, of a battery, an inductor labeled L, and a capacitor labeled C, with a switch that allows either the battery to run straight to the capacitor, or once the switch is in position B, as in this picture, the inductor and the capacitor form a series circuit and feed off of each other. From the aforementioned diagram, we will be using Kirchhoff's loop rule, which states that voltage on a closed loop will sum to zero. Using Kirchhoff's loop rule, we find that the voltage source minus the voltage of the capacitor plus the voltage of the loop, known here as E loop, will equal to zero. The voltage of the capacitor is equal to charge over its capacitance, and the voltage of the inductor, E loop, is the negative inductance times the change in current with respect to time. Plugging all this in, we find that the voltage source is equal to charge over capacitance minus inductance times the change in current with respect to time, and all that is equal to zero. Taking the voltage of the capacitor and the voltage of the inductor to the right side, we have an equation that equals E source is equal to the charge over the capacitance plus the inductance times the change in current with respect to time. You can rearrange this formula as long as you have 4 of the 5 variables and find any one of the 5 variables. So we will be using the equation Q is equal to Q max times the cosine of the square root of 1 over LC times T. This will give us the charge for our circuit. Taking the derivative of charge will give us the current, and this is equal to the equation negative Q max over the square root of LC times the sine of square root of 1 over LC times T. The derivative of the current is equal to the second derivative of the charge with respect to time, and this is the di over dt that we were talking about that's associated with the voltage of the inductor. This value is equal to the negative Q max over the inductance times the capacitance times the cosine of the square root of 1 over the inductance times the capacitance times time. Here we have our first sample problem. This one is actually from the textbook, Surway and Jewett, Physics for Engineers and Scientists. And it says that the inductance of the circuit is 2.81 millihenries and the capacitance is 9 picofarads. The capacitor has been fully charged to a value of Q max is equal to 1.08 times 10 to the negative 10 coulombs, and we're asked to find the voltage at T is equal to 0. Here I've listed what I've been given, and I've also listed the equation that we saw a few slides ago, that the source voltage is equal to charge over capacitance plus the inductance times the change in current with respect to time. So we've been given everything except for the change in current with respect to time, and except for the charge at the time 0. Well, noting that cosine of 0 is 1, the charge will be equal to Q max, which we see here. Additionally, we were asked to find the change in current with respect to time, and that can be found by plugging Q max and dividing it by the inductance times the capacitance. Again, cosine is going to be equal to 1 because time is 0. And that gives us negative 4,247.1 amps per second. Plugging all of this into the source voltage equation from the beginning, we find that the voltage source is equal to 12 volts. I don't know about you, but I really don't want to be doing equations and typing numbers into my calculator and potentially entering wrong values. I'd much rather write a script and have the computer do it for me. And that's what we did today. That's what the main crux of this presentation is. So here is my MATLAB script code. It is essentially for finding the voltage of a series LC circuit when the inputs are known quantities. These quantities are the same that we were dealing with before, Qmax, L, C, T, and Di over dt. And the outputs would be the electromotivity or source voltage. The user will be asked to input values of Qmax, inductance, capacitance, and time in their SI units. And the computer will actually calculate values for charge, amperage, changing current with respect to time, and the source voltage in about 5 seconds. So we've been asked to find the voltage of a battery when the capacitance is 1/2 microfarad, the inductance is 2.81 millihenries, and the maximum charge is 7.5 times 10 to the negative 5 coulombs. Well, all you have to do is enter these values into MATLAB and press enter, and the answer will be displayed as a 150 volts for the source voltage. Or we can do all this crazy complicated math and still get the same answer. I don't know about you, but I would much rather use the MATLAB script. So this brings me to my final point, that in this scenario, we only found the source voltage, but as I mentioned earlier, the equation can be rearranged, as well as the script can be rearranged to find any one of the 5 variables, as long as you know 4 of the variables or are able to calculate 4 out of the 5 variables. This makes this script extremely versatile, and it's scalable. It can be used along a wide array of purposes. For instance, I use it to simplify my Physics 2 homework, but somebody who works at an engineering firm might use it so that they can pre-prototype. They can build a circuit on the computer and plug in all the different values and get the source voltage that they want, or the inductance that they want, or whatever value, without actually having to go through the process of building a circuit board and taking the time to get the product. It's extremely versatile. It's extremely simple to use a MATLAB script, and I think that there's no other way to do it.